This time, the third of the quarterfinal contest is going to feature Wesley Grammar School, Anglican Senior High School, Kumasi, and St. Louis Senior High School. Happy to introduce the Girls Super Bonanza. This is a special activity by GOIL PLC. In the last round of competition, if any school solves all 4 riddles, they get 2,000 Ghana cedis from GOIL. If they solve 3 out of the 4 riddles, they get 1,600 Ghana cedis. If they solve 2 out of the 4, they get 1,000 Ghana cedis. And if they solve even 1, they get 500 Ghana cedis. Thank you, girls, for the Girls Super Bonanza. Before we meet the contestants, I would like to acknowledge our sponsors. The National Science and Math Quiz is proudly sponsored by the Ghana Education Service in partnership with GOIL PLC, and supported by Joy News, AT, Prudential Life Insurance Ghana, Pepsodent Toothpaste, Better Malt, Ghanaian Academic and Research Network, Coronation Insurance, Accra College of Medicine, Academic City University College, Cowbell, Bell Beverages, GTP, Newmont Ghana, Africa World Airlines, and YFM. My name is Elsie Efa Kaufman. I am an associate professor of biomedical engineering at the University of Ghana. I'm also the dean of the School of Engineering Sciences, University of Ghana. Thank you. Now, let's meet the contestants. Wesley Grammar School is represented by
Francis Adonson, Richmond Ufui.
You're welcome, gentlemen. How are you?
You're very fine.
When was the last time you were in the quarterfinals?
It's never been.
It's your first time? Yeah. Are you sure?
Yeah.
All right, then congratulations. Special congratulations to you. You know this is our 30th anniversary. When did you start watching the program?
When I was in GHS.
GHS. Did they contribute to you deciding to become science students?
Yeah.
What did you like about it?
The mannerism of the question and how the facts in it makes sense.
All right. I know you're going to put in your best, so I won't ask you. I'm moving on. All the best to you.
Thank you.
St. Louis Senior High School is represented by
Innocent Philippa Efrie.
You're welcome, ladies.
Thank you.
How are you?
Well, thank you.
That's very good. You heard me asking about the 30th anniversary. When did you start watching the National Science and Math Quiz?
Since I was in class 6, I think.
Yes. And you, Pfizer?
Class 6 as well. Class 6 as well.
Yes. Which is your favorite round?
Personally, my favorite round is the speed race.
The speed race. And you? the same. I see. Did you like the speed race when you were in class 6?
At that time, there was
no speed race in those days. Okay, so we've been changing. All right, I'm happy you like the speed race. All right, I know you put in your best, so I wish you well.
Thank you very much.
Anglican Senior High School is represented by
Griselda Eningwati.
You are welcome, ladies and gentlemen. How are you?
You're fine, thank you.
Okay, I usually commend the schools, the mixed schools that field the young ladies. So, Anglican, big ups to you. All right. We are talking about NSMQ at 30 years. How long have you been watching the program?
2 years.
2 years?
About 3 years. About 3 years.
3 years. Okay. What attracted you to the program?
A speed race.
The speed race.
Yes, please.
The riddles. Okay. All right. If there was one thing we could change about the program, what would you change?
True or false? True or false?
True or false? We should scrap it.
Yes, please.
Okay. All right. That's somebody's favorite, you know. Anyway, I know you're going to put in your best, and so I wish you well.
Thank you.
The questions are simple and direct. I'm expecting simple and direct answers from you. If you answer your major question correctly, 3 points. If the question is incorrectly answered, it becomes available to the 2 remaining schools. A school may ring and attempt an answer. If right, a bonus point. If not, there is a penalty, 1 point. For questions that require calculations, you have 30 seconds to present your answer. If there are no calculations, you have 10 seconds to do so. Ladies and gentlemen, all of the questions are to be attempted once only. Best wishes to all 3 schools. I will begin with you, Anglican, but before that, let me tell you that this first one is one of those questions that I move around gathering correct answers. When I get to your school, provide me with a right answer so I can move on to the next right answer. No bonus for this first question. Is that all right? Okay, so this is the question. During the synthesis of a particular product in the laboratory, the actual yield of the product is always lower than the theoretical yield. Give only one reason to account for this observation. So Anglican, first choice. Yes, Bauer.
Incomplete reaction.
Yes. With the same question, St. Louis, next choice. Pfizer.
The influence of temperature and other external factors in the reaction or on the reaction.
2. Wesley Grammar, your turn.
Side reaction.
Yes, side reactions. This was a case where several things were possible. So let me share some of them. Some have been mentioned here. Incomplete reactions, so not every reactant molecule reacts complete to form the desired product. Side reactions, that's what we got from Wesley Grammar, leading to formation of unwanted products. And then why I gave you is really the experimental conditions. So the real world conditions may never match ideal or theoretical conditions. And so I needed you to link it to real world versus the experimental conditions, right? That's why I gave you partial for what you said. And then there are other things that are possible, experimental losses. So for example, you can lose some material during transfer and purification processes. You can have also impurities in the starter material. It's difficult to obtain 100% starter material. So all these things will lead to that. And then, of course, the last one, which I don't even want to talk about because I know our students are very good. They normally don't have these problems. Errors, measurement errors and human errors. We don't like to talk about those ones, but they can also lead to this situation. Are we okay? All right, good. Next set, I'm starting with a preamble to all schools. Preamble. When I get to your school, I will give you a description. Mention or name the device to which the description refers. Is that okay? Good. So, Anglican. It uses rotation to negate the effects of gravitational pull on plant growth, that is gravitropism, and development, graphimorphism. Yes, Bawa?
Clinostat.
Yes. St. Louis. It is commonly used to demonstrate phototropism. Pfizer.
It is a photometer.
No. It's a heliotropic chamber. Dark box, heliotropic chamber. With the same preamble, Wesley grammar. It can measure growth in length of plants in response to a variety of parameters, including temperature, sunlight, and water conditions. Adonte.
Ozanometer. Ozanometer.
Yes. Next set, 30 seconds with a preamble to all schools. Preamble. A binary operation star is defined on the set of integers z by a star b is equal to a squared minus b squared plus ab. Find x if... I hope you got your preamble. No response means yes. So, Anglican, x star 3 is equal to 9. Griselda?
X is equal to 3 or negative 6.
You can't be changing your mind. 2 out of 3. St. Louis, with the same preamble. X star 2 is equal to 11. Yes, Philippa.
X is equal to -5 or 3.
You are right. Wesley grammar with the same preamble. X star 4 is equal to 16. Yes, I don't think.
S is equal to -8 or S is equal to 4.
You are right. Next set, 30 seconds each. Anglican. Find the final temperature of 12 kilograms of a substance of specific heat capacity 2.5 kilojoule per kilogram Kelvin that absorbs 90.0 kilojoule of heat at a temperature of 15 degrees Celsius. Griselda.
18 degrees Celsius. 18.
Yes. St. Louis. Find the initial temperature of 8.0 kilograms of a substance of specific heat capacity 1.5 kilojoule per kilogram Kelvin, whose temperature increases to 52 degrees Celsius when it absorbs 48 kilojoules of heat. Philippa?
48 degrees Celsius.
You're right. Wesley grammar. Find the initial temperature of 5.0 kilograms of a substance of specific heat capacity 2.4 kilojoule per kilogram Kelvin, whose temperature increases to 64 degrees Celsius when it absorbs 72 kilojoules of heat. I don't think. Go ahead. That's right, but there's something wrong with his sound. With a preamble to all schools. Preamble. Give the systematic name of the major product formed when the given alkene reacts with hydrogen chloride. I hope you got your preamble. Again, give the systematic name of the major product formed when the given alkene reacts with hydrogen chloride. All right, Anglican, 2-methyl-1-butene. Yes, Griselda.
Position of the 2-methyl 2-chloro butane.
That's incorrect. Yes, go ahead, Pfizer.
2-chloro-2-methyl-butane.
That's the right one. Now your major question. One methyl cyclobutene. Pfizer?
1-chloro-1-methyl cyclobutane.
Yes. With the same preamble. 4-chloro-1-butene. I don't think that hand up. Go ahead.
1,4-dichlorobutane.
That's incorrect. Philippa.
1,3-dichlorobutane.
No. The right answer is 2,4-dichlorobutane. Time out.
Chlorobutane.
Yes. Okay, next set, 10 seconds. I have a preamble to all schools. Preamble. Mention the terms to which the description I give you refers. Is it okay? Or again? When I get to you, I will give you a description. Please mention or name what the description is referring to, right? Technical name for what I am describing. I hope that's all right now. Okay, so Anglican Senior High School. Stamens of a flower are united and are present as one bundle or a compound structure. Yes, Bauer.
Okay, so it is Monostaminate flour.
No, for bonus. Monoadelphos. Monoadelphos. With the same preamble, St. Louis. Stamens of a flower are free and numerous. Yes, Philippa?
Polyadelphos.
No, for bonus. I'll come back to you. Wesley grammar with the same preamble. Both anthers and filaments are fused, with the stamens appearing fused in the entire length. Yes, I don't think.
Synadelphos. Synadelphos.
No, for bonus. Okay, so yes, we had monoadelphos here, right? So you people decided that adelphos was the key word. All right, St. Louis is polyandrous. Okay, polyandrous. And then Wesley grammar, maybe if I had told them, it would have given you a hint. So it's a good thing I didn't say the answer then. Yours is synandros. All right. We live to learn. All right, 30 seconds with a preamble to all schools. Find the coordinates of the stationary points of the given curve. Did you get your preamble? Find the coordinates of the stationary points of the given curve. Anglican, your curve. Y is equal to x to the power 4 minus 8x squared plus 6. Griselda.
Okay, so the stationary points are 0, 6, 2, -10, and -2, -10.
You are right. St. Louis with the same preamble. Y is equal to x raised to the power 4 minus 2x squared plus 3. Philippa.
0, 3, 1, 2, -1, 2.
That's right. Wesley grammar with the same preamble. Y is equal to x raised to the power 4 minus 18x squared plus 81. Yes, Richmond.
We are having 0,81 and 3,-162 and -3,-162.
1 out of 3. The right answer, you got one of them right. 081. That was the one you had right. The other two are 30 and -30. And now let me use this opportunity for a bit of education. When you are calling out coordinates, what is all this comma, comma, comma? It's very inelegant. Huh? You read coordinates 081. No need for comma. Huh? Please, I hope we've learned something. All right. Next set 30 seconds with a preamble to all schools. In a bifilar suspension experiment, an object is suspended horizontally by 2 strings, each of length 2.0 meters and separated by 1.0 meter. Find the moment of inertia of the object about the oscillation axis for the given object mass m and oscillation period t, if gravity at the location of the experiment is 9.8 meters per second squared. Did you get your preamble? Okay, again. In a bifilar suspension experiment, an object is suspended horizontally by 2 strings, each of length 2.0 meters, and separated by 1.0 meter. Find the moment of inertia of the object about the oscillation axis for the given object of mass m and oscillation period t, if gravity at the location of the experiment is 9.8 meters per second squared. Now, Anglican, m is 1.5 kilogram, and t is equal to 2.0 times 10 raised to the power -2 seconds. Griselda.
Okay. 0.60 kilogram meter squared.
That's incorrect for a bonus. Okay, I'll hold on to it. With the same preamble, St. Louis, m is 2.5 kilograms and t is equal to 1.0 times 10 raised to the power -2 seconds. Yes, Faiza.
It is 2.5 by 10 exponent -1 kilogram meter squared.
That's incorrect for a bonus. Okay, holding on to it for the moment. Wesley Grammar, with the same preamble, m is 3.0 kilograms NT is equal to 2.5 times 10 raised to the power negative 2 seconds. Is that hand up, Richmond? Go ahead.
When you answer. Okay, so we have 6.8 times 10 raised to the power negative 8 kilogram meter squared.
That's incorrect for bonus. Okay, so Anglican, yours was 1.9 times 10 raised to the power negative 5 kilogram meter squared. St. Louis, 7.8 times 10 raised to the power negative 6 kilogram meter squared. And Wesley Grammar, 5.8 times 10 to the power negative 5 kilogram meter squared. Next set, 30 seconds. Anglican. A radioisotope has a half-life of 3.40 minutes. Given an initial amount of 38.4 grams, how many grams of the radionuclide will remain after 27.2 minutes? Griselda?
SF 2.30 grams.
That's incorrect. Go ahead, Philippa.
0.150 grams.
Yes. Now your major question. If it takes 11.2 hours to transport a radioisotope of half-life 1.6 hours from a laboratory to a hospital for diagnosis, what is the minimum amount of the isotope that has to be produced if 3.50 milligram of it is required? That is required for use. Philippa.
448 milligrams.
You are right. Wesley Grammar. After 8.96 hours, only 0.450 gram of a 57.6 gram sample of a radioisotope remains. What is the half-life of the radioisotope? go ahead. Pfizer?
1.28 hours.
You're right. Seconds. Anglican. Where will the image of a distant object be formed when a person using a concave lens to correct vision does not use the lens? Yes, Bawa.
Infinity.
That's incorrect for a bonus. In front of the retina. Okay. St. Louis, what is the function of the tapetum lucidum in animals? Philippa?
It helps nocturnal animals to see at night. That is, it helps in night vision of animals.
Yes. Wesley grammar. Wesley grammar. Why is it that a cornea transplant is almost never rejected in humans? Yes, Richmond.
Madam, due to the compatibility of the cornea that...
Please speak up.
Due to the compatibility of the cornea that it is not rejected by the human being it is being transplanted to.
I'm not accepting it for a bonus. You are basically telling me what I had told you in the question, right? The fact that it's not rejected means it is compatible. But what is it that makes it compatible? The people making noise, can you answer this one? Well, the cornea does not have a blood supply. And since there is no blood supply, there is no access of the immune system to come and cause a rejection. Isn't that amazing? How many of you are willing to donate your corneas for transplantation? All right. Next set, 30 seconds with a preamble to all schools. Preamble. Find the relation between y and x of the form y squared is equal to f of x if the point P with coordinates x, y is equidistant from... Did you get it? Or shall I repeat? Repeat. Okay. Find the relation between y and x of the form y squared is equal to f of x if the point P with coordinates x, y is equidistant from an Anglican, the point A with coordinates 3, 0, and the y-axis. Yes, Bawa.
Y squared is equal to 36x.
That's incorrect for bonus. No. I'm holding on to the answer. With the same preamble, St. Louis, the point B with coordinates -4, 0, and the y-axis. Yes, Pfizer?
Simplify. Y squared is equal to 16x plus 64.
That's incorrect for bonus. All right. With the same preamble, Wesley grammar. The point C with coordinates 5, 0, and the y-axis. Richmond.
Y squared is equal to 10x minus 25.
You are right. Somebody finally cracked the code. All right. So, Anglican, your answer was y squared is equal to 16x minus 9. St. Louis, yours was y squared is equal to -8x minus 16. All right. On we go. Last set of questions for the round. 30 seconds each. Preamble to all schools. Preamble. Assume an incompressible fluid in the given situation. That's all. I'm not repeating that. You heard it. So, Anglican, fluid flows at 1.6 meter per second from a pipe of diameter 0.25 meter into a second pipe of diameter 0.20 meter. Find the fluid speed in the second pipe. Yes, Bawa.
Okay, so we have 2.0 meters per second.
That's incorrect. Yes, Philippa.
2.5 meters per second.
Yes. Your major question. Your major question. With the same preamble. Fluid flows from a pipe of diameter 0.40 meter into a second pipe of diameter 0.20 meter, and you have to find the fluid speed in the first pipe if its speed in the second pipe is 2.2 meter per second. Yes, Philippa.
0.55 meters per second.
You are right. Wesley Grammar. With the same preamble, last question, Wesley Grammar. Fluid flows at 8.1 meter per second from a pipe section of diameter 0.20 meter into a second pipe of diameter 0.30 meter. Find the fluid speed in the second pipe. Richmond, there's that hand up. Please go ahead.
2.30 meters per
That's
second.
incorrect. Go ahead, Philippa.
3.6 meters per second.
Yes. And that's the end of the first round. At the end of the first round, Anglican Senior High School Kumasi has 14 points. Wesley Grammar School has 16 points. St. Louis Senior High School has 29 points. Four more rounds to go. Four more. We are at the top of the second round. The second round is known as the Pepsodent Speed Race. The Pepsodent Speed Race, sponsored by Pepsodent toothpaste. Every smile matters. All right. So in this round, I'm going to be presenting the questions to all three schools at the same time. For an opportunity to answer a question, you must ring for it. May I hear your bell, Wesley Grammar School? Thank you. Thank you. Thank you. If you ring and answer correctly on the first attempt at the question, 3 points. If it's a second attempt, 2 points. If it's a third attempt, 1 point. But be very careful, because if you attempt to answer a question and you are unable to provide a right answer, possibly because your answer is wrong, or you do not provide an answer within 3 seconds of ringing, you lose a precious point. In order to indicate whether you have used up your 3 seconds, we have a bell. May I hear the bell, please? When you hear that bell, it means you have forfeited your chance. Your answer has been taken. Whether you were saying, Madam, we have, whatever drawn out thing you were saying, that's the answer. So we move on and you get your negative point. That's all. Right? Okay, I hope that's clear. For questions requiring calculations, you have 30 seconds to present your answer. If there are no calculations, you have 10 seconds as usual. Best wishes, everyone. First set of questions, 30 seconds each. First one. At 180 degrees Celsius, methanol is formed from a reaction of carbon monoxide and hydrogen gas in an equilibrium reaction with partial pressures in ATM of 0.80, 0.40, and 2.5 respectively. Please calculate the equilibrium constant of this reaction. Yes, Philippa. Go ahead.
The equilibrium constant is given by 4.7.
That's incorrect. Right answer is 0.32. Next one. How many moles of acid is required to convert 5 moles of iodate to iodine in a reduction reaction? Bawa?
6.
That's incorrect. Philippa.
30 moles.
Yes. By the way, if you don't raise your hand, I am at liberty to call either of you. Next one. Calculate the sum of the average oxidation states of sulfur in sulfur dioxide, sodium thiosulfate, and aluminum sulfide. The right answer is 4, positive 4. Next set, 30 seconds each. Factorize the expression x cubed plus 8x minus 9. Yes, Bawa. Go on.
We have 2 brackets multiplying. In the first bracket, x minus 1. In the second bracket, x squared minus 7x minus...
That's incorrect. Who else rang? Yes, Faiza.
We have 2 brackets multiplying. In the first bracket, we have the expression x minus 1. And in the second bracket, we have the expression x squared plus x plus 9.
You are right. Next one. Evaluate and simplify. The expression tangent of 60 degrees minus tangent of 45 degrees. Okay, Griselda.
Okay, we have f2 minus root 3.
You are right. Next one. I have a lot of things to say, so please, if you can keep calm for us, we'll be very grateful. Okay. So find the matrix product. I have two matrices multiplying. The first matrix is a 3 by 3 matrix with elements 1, 0, negative 2, 0, 2, 1, negative 2, 0, 1. And the second is a 3 by 2 matrix with elements 2, negative 1, 1, 2, and 1, 1. Yes, Bawa.
No solution.
No. Wow. Is it because you haven't seen 3 by 3 matrices before, multiplying 3 by 2 matrices? Is that the reason why? People. It has a very big solution. It has a solution. The solution is a 3 by 2 matrix with elements 0, negative 3, 3, 5, and negative 3, 3. Go and figure out how to do it. By next year, this should be a joke for you, right? All right, next set, 30 seconds. Anglican, find the RMS. Pardon? I was so upset by the matrix problem. Okay, it's a speed race. It's not for you, Anglican. It's for all of us. All right, so 30 seconds each for this set. So find the RMS current in a circuit composed of a 16 ohm resistor in series with a 25 Henry inductor when an AC source of frequency 1 over pi hertz and RMS voltage 3 volts is applied to the circuit, leaving your answer in terms of surge. Root 34 over 34 ampere. If a Bohr hydrogen atom is in the state with angular momentum 5.27 times 10 raised to the power negative 34 joules second, what is the transition? Yes. Yes, Bawa.
It's 5.
That's incorrect. What is the transition energy in electron volts to the level just below its state? Yes, Pfizer.
0.307 electron volts.
Again?
0.307 electron volts.
That's incorrect. This one hits. 0.306 electron volts. All right, next one. Find the linear thermal strain induced by a 3.0 Kelvin temperature change of an object of linear thermal expansion coefficient 2.4 times 10 raised to the power -5 per Kelvin. Yes, Bawa. Go ahead.
7.2 times 10 to the power -5.
You are right. Last set of questions for the round, 10 seconds. 10 seconds. What name is given to the sites of active RNA synthesis? Yes. Go ahead, Bawa.
Okay, it is the polyribosome.
No. They are called Balbiani rings. Balbiani rings. Next one. What name is given to the layer of square cells located just under the bran layer, which separates the bran from the rest of the cereal grain? All right, it's the aleurone layer. Last one for the round. What is the oxidation state of iron in hemoglobin? Yes, Bawa.
+3.
That's incorrect. Kuran. Yes.
+2.
Pfizer.
+2. +2.
Yes. And that's the end of the second round. At the end of the second round, Anglican Senior High School Kumasi has 14 points. Wesley Grammar School has 16 points. St. Louis Senior High School has 33 points. Round 3. In this round, we have the problem of the day. And at stake in the round is the Prudential Life Insurance NSMQ star. The star is an award to any team that earns a perfect score in the problem of the day, and at this stage it's worth 2,800 Ghana cedis. The NSMQ star is sponsored by Prudential Life Insurance Ghana. For every life, for every future. Thank you very much, Prudential Life Insurance Ghana. All right, so the problem of the day is a bit longer than what you've seen so far. From the time I ask you to begin, you will have 4 minutes to present your answer on the screen behind you. As mentioned, you are working towards a perfect score of 10 points. 10 points. All right, so contestants, you may rise, leave your pens on the table. Don't touch the problems yet. Make yourselves comfortable standing up. All right, now you may turn over your sheets so that we can read the problem of the day together. Problem of the day. A conducting sphere of radius 0.20 meter is charged to a potential of 2.7 kilovolts. A. How many electrons must be added to or removed from the sphere to obtain a surface potential of negative 2.7 kilovolts? B. Find the magnitude of the electric field on the surface of the sphere at 2.7 kilovolts after 7.5 times 10 raised to the power 10 electrons are removed from it. And finally, C. Find the change in the magnitude of the electric field on the surface of the sphere at 2.7 kilovolts when a grounded conducting wire is briefly connected to the sphere. Contestants, this is your problem of the day. You may now begin. The contestants have presented their answers. Before I award the marks, let's look at the suggested solution from the consultants. This is a problem from physics. So we have a conducting sphere that has a given radius of 0.20 meter and is charged to a potential of 2.7 kilovolts. The first question was, how many electrons must be added to or removed from the sphere to obtain a surface potential of negative 2.7 kilovolts? Okay, so this is how to approach this question. The charge on the sphere is Q. Let's call it Q. Standard convention, Q. And this is equal to 4 pi epsilon naught. Epsilon naught has the usual meaning, multiplied by the potential difference times R, where V, of course, is the surface potential and R is the radius. At a positive potential of the 2.7 kilovolts, Q is going to be 2.7 times 10 raised to the power 3 volts, multiplying 0.20 meter and divided by 9.0 times 10 to the power 9 farad per farad meter. Okay. So if you do this calculation, what you will arrive at will be 6.0 times 10 to the power -8 coulomb. That is the charge. Okay, so this is a charge N. This is a charge on N protons. Okay, so this is a charge on N protons. And if we want to find out what N is, we take the charge and divide by E. And what we will get is that's the electron charge, and we'll get 6.0 times 10 to the power -8 coulomb divided by 1.6 times 10 to the power -19 coulomb. This should give you 3.75 times 10 to the power 11. Okay, so that's our N. We have the number of protons now. To obtain the surface potential of -2.7 kilovolts, we need 2N, twice. We need twice the number of electrons in order first to neutralize the sphere and then go over to what we need it to be, right? So to obtain the surface potential, you get -2.7. The -2.7 kilovolts will take 2N, so we need twice of that. So we calculated N to be 3.75 times 10 to the power 11. So this gives us 7.5 times 10 to the power 11 electrons to be added to neutralize the sphere, and additional N to bring the potential down to the negative of the initial potential. Okay, if you're able to do all of this, 4 points. So let me see how I was going to break down this. If you're able to correctly calculate for the Q, the 6.0 times 10 to the -8, I would give 1 point. If you're able to get the N, which is 3.75 times 10 to the power 11, that is another point. And then finally, realizing that you need to double that and then finish the calculation off to get 7.5, I add 2 more points to get you to the 4. So that's how the mark allocation went for this first part. Okay, so for the second part, they were to find the magnitude of the electric field on the surface of the sphere at 2.7 kilovolts after 7.5 times 10 to the power 10 electrons are removed from it. So if we have this number of electrons removed at 2.7 kilovolts, the charge would increase from this Q, which we calculated, the 6.0 times 10 to the power -8, to go to, let's call it Q prime. And we can calculate that Q prime to be Q, the old Q, plus small n times electron charge. So we will wind up with 6.0 times 10 to the power -8 plus 7.5 times 10 to the power 10 times 1.6 times 10 to the power -19 coulomb. And this will become, if we sort it out, we'll get 7.2 times 10 to the power -8 coulomb. The surface electric field, which is normal to the surface, will then have a magnitude. And I'm just going to tell you the formula. If you want to do this, you can sort it out when you get back. So E is going to be equal to the Q prime, the new Q, right? Q prime divided by 4 pi epsilon naught R squared. We substitute the values and we should arrive at 16 kilovolts per meter. This is worth 3 points. And then finally, Contestants were to find the change in the magnitude of the electric field on the surface of the sphere at 2.7 kilovolts when a grounded conducting wire is briefly connected to the sphere. Interesting scenario. So the magnitude of the surface electric field on the sphere when its potential is 2.7 kilovolts is going to be V divided by R. So you take 2.7 times 10 to the power 3 kilovolt over 0.20 meter, and you should arrive at 13.5 kilovolts per meter, which you can approximate to 14 kilovolts per meter. So the wire grounds the sphere. I hope you realize that if you even got that far. The wire grounds the sphere, thereby neutralizing it. The surface electric field is then 0, so the difference between the initial and the final electric fields is just 14 kilovolts per meter. This is also worth 3 points to get a total of 10 points. This is what was expected of the contestants. Now, Anglican. A lot of confusion right from the beginning. Even your numbering, I have A, B, and C. For you, I'm seeing 1, 2, and 3. I've decided I'm penalizing 1 point for things like that. Okay, so you already have -1. Keep note. Then, your calculation of Q for the first part, that was right. You had 6.0 times 10 to the power -8 coulomb, which is exactly what I was looking for at that stage. Remember, I was awarding 1 point for it. So you get that 1 point, and then I take it back. The rest, in fact, went me and fakoto anyankwan. And so, at the end of the day, I have to award you 0. Wesley Grammar, your situation was also very, very serious indeed. Your calculation, you set out to calculate for Q, and you started that calculation. Remember, I'm only offering 1 point for this. So setting up, I can't give you half. At the end of the day, your calculation, you are 2 orders, no, even more than that, 3 orders of magnitude off. 6 times 10 to the power -11 instead of -8 coulomb. So that's not right. Then you go on, the things you are doing for B are not going to lead you anywhere. And then the things that you were doing for C, when you got to C, yes, you did set up once again. Unfortunately, so for the setup in that case, I will give you 1 point. But the answer you got at the end of that calculation is not what, again, you were 10 to the power. So remember, it's supposed to be 14 kilovolts per meter. You were somewhere else. It didn't work out that way. So just for setting that up, for setting the C up, I give you 1 point, and that's all that you also got. 1 out of 10. St. Louis. St. Louis, I'm happy to say that you don't have any trouble with the first A. Remember, I was offering 4 points for A. I'm giving you all 4. But you couldn't handle B or C. Nothing there. And so at the end of the day, you have 4 out of 10. That That is another potential NSMQ star biting the dust. I'm not happy. That's the end of the problem of the day and the end of round 3. Senior High School Kumasi would like to effect a substitution. Griselda, it's been a pleasure. Best wishes to you. Atiemo is coming on for Griselda. Atiemo, you are welcome.
Thank you.
Round 4. In this round, I'm going to be presenting you with statements. When you receive a statement, please consider the statement very carefully and let me know whether it's true or false. If you are right, 2 points. If you are incorrect, you lose a precious point. You may choose not to respond, in which case that statement is available to the 2 remaining schools. A school may ring and attempt an answer. If right, 2 full points. If not, there's a penalty, 1 point. For most of the statements, you will have 10 seconds to provide an answer. But if there are calculations involved, I'll let you know. Then you'll have 30 seconds. Best wishes, everyone. Anglican. Now, let me start with a preamble to all schools. Preamble to all schools, after which I will come to you, Anglican. In the plasma membrane, that's a preamble. So, carbohydrates are directed to all sides of the membrane randomly. Atiemo.
False.
You're right. Carbohydrates always face the lumen of cells. Yes, Pfizer? True. No, that's a false statement. Carbohydrates always face inward to the non-polar portion of the membrane. Yes, Richmond?
False.
You're right. Actually, the carbohydrates always face outwards, towards the extracellular space. All right. So all of those things were false. All right. Next one. Anglican. When a siren approaches a stationary observer, the frequency perceived by the observer is greater than the frequency of the siren in its rest frame. Atiemo?
True.
Yes. A siren approaches a stationary observer at constant speed, the frequency perceived by the observer increases as the siren gets closer to the observer. Yes, Pfizer? True. Oh, no. That's a false statement. a siren approaches a stationary observer, the frequency perceived does not depend on the distance between the siren and the observer. Yes, Richmond?
False.
No, that's a true statement. For this next set, I'm going to give you 30 seconds. You may not need it, but you can have 30 seconds, all right? Anglican. The equation 2x squared minus 5x plus 4 is equal to 0 has real roots. Atiemo.
False.
You're right. The equation 3x squared plus 6x minus 2 is equal to 0 has distinct real roots. Pfizer? True. Yes. The equation 4x squared minus 4x plus 1 is equal to 0 has identical roots. Yes, Richmond?
True.
Yes. PCl3 is a polar molecule.
False.
Yes. No, it's a true statement. NO2 is a polar molecule. Yes, Pfizer? True. Yes. PCl5 is a polar molecule. Richmond?
False.
Yes. Anglican. The Hardy-Weinberg equilibrium operates in the absence of gene flow.
Okay.
Atiemo.
False.
No, that's a true statement. The Hardy-Weinberg equilibrium operates in the absence of mutation. Pfizer? True. Yes. The Hardy-Weinberg equilibrium operates in the absence of natural selection.
False. False.
No. That's a true statement. Anglican, I'm back. The normal force on an object does not always equal the weight of the object. Yes, Bauer?
True.
Yes. The normal force on an object at rest always acts vertically upward. Pfizer?
False.
Yes. Normal forces occur in equal opposite pairs. Richmond?
False.
Oh, that's a true statement. For the next set, I have a short preamble to all schools. Preamble. A linear pair of angles are, that's a preamble. A linear pair of angles are, Anglican, congruent. Yes, Bauer?
It's false.
Yes. Complementary. Yes, Pfizer?
False.
Yes. Supplementary. Richmond?
True.
Yes. Last set of statements for the round. The degree of unsaturation in butane is 2. Yes, Bauer?
False.
No. That's a true statement. The degree of unsaturation in cyclopentene is 2. Yes, Pfizer?
False.
No. It's a true statement. Last statement to you, Wesley Grammar. The degree of unsaturation in benzene is 4. Richmond?
False.
It's also a true statement, and so that means none of you got these statements right for this set. And unfortunately, we've come to the end, and so it's the end of the round. Of the fourth round, Anglican Senior High School Kumasi has 21 points. Wesley Grammar School has 21 points. St. Louis Senior High School has 44 points. We will have round 5, whether you like it or yes. Because round 5, that is where the gold super bonanza kicks in. You may not want round 5, but these contestants want round 5. Because if they solve one riddle, they get 500 Ghana cedis. If they solve 2, they get 1,000 Ghana cedis. If they solve 3, they get 1,600 Ghana cedis. And if they solve all 4, they get 2,000 Ghana cedis. Sponsored by Goal Good Energy. All right, round 5. Patience, patience, patience. You will get your chance, trust me. In this round, I'm going to ask you to solve riddles. I will be reading out the clues. In order to get an opportunity to solve a riddle, you must ring for it. So now, let me hear your bell, Wesley Grammar. Thank you. Yours, St. Louis. Thank you. And yours, Anglican. Thank you. If you solve the riddle on the first clue, 5 points. On the second clue, 4 points. On the third or any clue thereafter, 3 points. There are 4 riddles. Best wishes, everyone. And I need you to cooperate with us, please. Allow them to earn all those super bonanza CDs. All right, first one. I am an alcohol and a very useful one at that. When oxidized, I form a ketone. I am a disinfectant and often used in wound cleaning and in hand sanitizers. When dilute, I am commonly referred to as rubbing alcohol. I may be prepared from the hydrogenation of acetone. Yes, go ahead. Which of you? I don't think.
Ethanol.
No. I continue. My chemical formula is C3. Yes, go ahead. Atiemo.
2-propanol.
Again?
2-propanol.
Yes, you are right. Yes, 2-propanol. By the way, you can recognize this one as isopropyl alcohol, right? Okay, good. Next one. We are a group of antifungal agents. We have applications in agriculture, the food industry, the paint industry, and medicine. We are used to prevent infections in people with weak immune systems. Our mechanism of action involves interfering with synthesis of the fungal cell membrane. Sodium benzoate and potassium sorbate are both examples of us that are widely used in the preservation of food and beverages. We are antifungal agents that inhibit the growth of fungus without killing the fungus. So who are we? Yes, I don't think.
Antiseptics.
No. Who else rang? Yes, Pfizer?
Antibodies.
Hey. Did you ring? Yes, Anglican. Bauer?
Fungicide.
No. Anyone? Okay, the right answer is fungistatics. Fungistatics. Next one. I am a derivative. To be precise, I am a type of derivative. There's nothing implicit about me. Yes, I don't think. Go.
Implicit differentiation.
No. Did anyone else ring? No. Okay, so I continue. You can say I am a discriminant for curves. I determine the nature of the stationary. Yes, Anglican. Atiemo.
Gradient.
No. Did you ring? They didn't ring. Okay, so St. Louis for you. I determine the nature of the stationary points of a curve. For a maximum point, I am negative, and for a minimum point, I am positive. Who am I? Yes. Pfizer.
Second derivative.
You are right. Last one. I am a physical quantity. I am a scalar quantity. I cause energy changes. An example of my rate of change is dot product of force and velocity. Yes. Atemo.
Power.
No. I am that which is done when the point of application. Yes. Richmond.
Pressure.
No. For you, St. Louis. St. Louis, for you. I am that which is done when the point of application of a force moves in the direction of the force. Who am I? Pfizer?
Wake.
Yes. And that's the end of the 5th round.